elective, and I am going to discuss module 4. So downstream processing 17CH 754. Okay, so please look at the syllabus. So this is unit 4. One minute, I'll share the screen. Sorry. Okay. So can you see the screen? All of you can see the screen? Yes or no?
Yes, sir.
Can you hear my voice? Okay. So this is
Yes.
module 4, where we are going to discuss product recovery. So in chemical process industry, there is always a problem of product purification. This is one of the most energy intensive, as well as, and economics is also involved more in product recovery. Usually whenever you select optimum design is based on knowledge and understanding of a process. Means A is producing a large quantity of a product, where B is producing a relatively less quantity of a product. So what is best choice? Best choice in terms of a yield is A, and in terms of yield B is less. But when you compare the product quality, the product purification, if the product purification of a B is very, very high, then I'll go for B. So because whatever the product A is giving a high yield, but the product is not in a good condition, means you have to employ more purification method. So this purification method will always, okay, consume more, okay, money on the process. So therefore we'll be buying 20 rupees liter water bottle, because reverse osmosis is employed. Okay, these are the processes which are generally very, very costly. Therefore, what is a basic operation which are involved in a purification of a final product? So which will be depending on degree of purification. So how you are going to purify? So it may be by using a chromatographic method, and one of the most widely used process is adsorption, or it is usually called as sorption. So which will be, we are selecting some kind of a solid. On the surface we are going to accumulate whatever the known quantity, and product will be produced. So that is one method. And chromatography is a method where one will be stationary phase and another will be moving phase. So therefore these are the two process which we generally employ in a process industry to separate the products into more constituents. Why the product should be purified? Suppose the product is containing a unwanted component in a final ingredient, then it should be referred as a impurity. Impurity is anything which you don't want, so it is not required in a final product. How this impurity will be removed? Sometime you can take an example of laboratory chemicals, which will be available as industrial grade and laboratory grade and analytical grade. Industrial grade, suppose if you buy a ethanol, it will be around 30 to 40 rupees per liter. Suppose if you are buying for a reagent, then it will be around 200 rupees. But if you are going for an analytical grade, then it will be in terms of 1000. So why this cost is increasing? The cost is increasing because the purification method you have employed in your product is increasing. So therefore Economic grade means it is an industrial grade, will be very cheaper because it contains a huge quantity of impurity. When you are using for analysis, then your reagents should be very purified. So therefore this is what understanding of the purification, why the purification is very costly, and always we'll discuss the purification at end of the course, because this will be learned and this will be understood at the end, because it involve more amount of energy. Okay, and it will always after the process, it is final process. After this we are going to pack the product and will reach the customer. So therefore purification is very important. Here what we are discussing in a purification is restricted to sorption process. In sorption, the interaction between solid phase and a liquid phase is exploited to separate the component. So therefore we are going to exploit the phase or understand the phase. Usually this will be by van der Waals interaction. Van der Waals means physical interaction. After that you can remove easily. Sometime it will be polar forces, sometime it is ionic, or it will be affinity. So therefore if it is a polar means we need to identify a appropriate solvent or a solid which will affinity towards it. Suppose the polarity of a solvent should be selected so that the separation will be easier. The simplest way is a solubility, it will be easier. So ethanol, suppose if I want to separate a ethanol from a solution, then you need to identify what is the solubility of a ethanol, where it is going to soluble, in which component it is going to soluble. Choose that and then you start the process so that ethanol will enter into that component. Okay, so this is one of the method. So usually in final purification method we never employ any temperature. So temperature, if at all it is employed, it is very less. It is not like evaporation, not like distillation, not like other cracking, or so where the high pressure and temperature is involved. The final product will be separated based on the composition of the product, how they are going to soluble, how they will affinity towards one of the component, how they are entering from one phase to other phase. So these will be used to separate. Therefore these will be categorized into adsorption process or sorption process or chromatographic process. What is the difference between adsorption, sorption and chromatography? Sorption is simply a solid on which you are going to separate the process. What you are doing, I am taking a quantity to be removed, directly I am adding. So therefore it will be look like a step change. The concentration of the product where you are going to remove from the process is a step. So therefore it is going to increase from 0 to continuous. But in a chromatography you cannot continuously inject a product. So therefore it will be in the form of a pulse. So therefore pulse of a quantity of a product will be added, that will be removed. Later again a pulse. Pulse means it is a known quantity of a product, or the product need to be analyzed, will be added into the column and it will be separated. Best example of chromatography, application of a chromatography as well as the sorption will be a one and the same. In chromatography what happened, so one will be solid, other one will be moving. So therefore we have a solid as well as a solvent. So whatever the solvent which will move, and if it will be having a more affinity to the solvent, it will take a very long distance. If the affinity is less, then it will leave there only. So therefore I'll show, okay, one of the okay, let me one more. News here. Okay, look at this. Okay, can you share this board? Can you see the board? Yes or no? Are you listening? Hello?
Yes, sir.
Yeah, okay. See here. Suppose you take a, okay, simple, okay, you might have observed this also. When you are writing anything on a piece of paper, and then suddenly the paper is come in contact with the water, what you can see, whatever the ink or whatever the mark you have made on the paper, it will start traveling. At the edges, you can see the color of a blue, red, as well as a light yellow. So why? Because the black dye is made up of a different colors. These colors will have a different wavelength, so therefore we can see it. So therefore, these will be having a capability to dissolve in a various solvent by means, by chance. If your written material will come in contact with the water, you can see the edges of your paper with a different color. So therefore it is one of the easiest understanding of a chromatography. Therefore, what is a solid phase? The solid phase is a paper. What is the mobile phase? Mobile phase is a water which will be moving from a that particular place. Suppose if I can take a simple example. So this is a reference line, and then I am making a mark over here. And then what I am doing, I am contacting this one with a solvent, known quantity of a solvent. And then after some time, what happened? This solvent will travel upward. Okay, you can see here. This solvent will travel upward, and when it will be traveling, it will move, and it will somewhere stops here, and again further it will move, and somewhere it will stop here. Okay, see here. You can easily identify whatever the component which is taken for the analysis will have a component A and component B. So this is one of the method to identify how many components are present in the mixture. So therefore this is one of the easiest method to analyze, which is called a paper chromatography or thin layer chromatography. So paper chromatography is, here the paper is a stationary phase, and whatever the solvent you have selected for the operation is a mobile phase. This will move upward. While moving, it will be taking a 2 points, A and B. So why A is stopped here? A will be having a less affinity to the solvent, therefore it cannot carry further, it left over there. And B will be having a more affinity towards the solvent. Means A will be having a more affinity to the stationary phase, where B will be having a more affinity to the solvent phase. So this is what a chromatography. Chromatography is a separation. It is based on their affinity towards mobile and stationary phase. Whereas a sorption is a process where your product will be adsorbed on the surface of the solid. So usually adsorption will be seen in a large scale production in the beginning itself. So therefore you can use a different type of a carbon material where you can purify the water in a huge quantity. But as far as the chromatography is concerned, so which will be used at the end of the operation, and usually this will be employed to separate highly valuable chemicals, antibiotic, even the herbal extracts have been identified by means of a chromatography. This is the clear-cut definition of adsorption and chromatography. Both are the same. What happened in adsorption? The preferential concentration of a component on the solid surface is separating phenomena. While in the chromatography, the separation is caused by a difference in affinity or interaction of a components with the solid phase. So this is what a difference between adsorption and chromatography. Adsorption has been applied as a concentration and purification technique on a large scale for commodity chemicals as antibiotics and other small molecules for many years. Adsorption has been mathematically described. So in your mass transfer operation, how the adsorption process will be discussed. It is a Freundlich and Lagner adsorption isotherm, and you are going to calculate what is the slope and intercept. So those are the quantities of a adsorption. Okay, so chromatography is a simplest method. So therefore we are going to discuss what is a chromatography. So number one, so how this separation is possible. So first one is based on the size of a particle. How the separation is possible? Separation is possible based on the size of the particle. The size of the particles play a very important role in a separation of the particle. You all know. So which will be come across in a membrane separation, or you can separate this by using a simple sand filtration. You take a muddy water, take a clear sand of a gravel of a different size and fill in a bottle and put your wastewater on the top. You can see the purest form of water on the bottom. This whatever the color, whatever the dust which will be accumulated based on the size, this is one of the size separation. Next one is van der Waals force. So it is a physical separation or physical adsorption where van der Waals force will be play very important role. Van der Waals force means it is a temporary attraction affinity towards the particular adsorbent, and after the process you can regenerate this adsorbent and use it. And then number 3 is based on the polarity. So you can see whether which solvent is polar and non-polar based on the application. I am going to discuss all these factors in a later stage where we are going to discuss individually TLC, gas chromatography, affinity chromatography, column chromatography. I am going to discuss a theory. So it is a general discussion of separation and purification. So therefore you need to choose appropriate solvent. So it is based on the polarity, and then it is a sometime you can see ionic. So this one, so based on their charge, the particles should be get separated. So you can take an example of electrodialysis. It will not chromatography. I'm just giving some example which you have already learned. And number 5 is affinity. So affinity will be usually in the form of enzyme, which will be affinity towards a particular thing. So in your body you have lots of enzyme which will be helping in digestion of the food. Saliva will be digesting almost 80% of the carbohydrate. Again you will enter into the gut, trypsin and pepsin, so which will play a very important role in a digestion. So therefore these will be affinity. We'll be discussing this one at the end. And these will be a basic objective and understanding of a process. I'll stop this here. I'll share the slides now. I'll just try to explain. So this is difference between adsorption and chromatography. So therefore it is a traditional adsorptive separation and chromatic separation. So therefore I have explained what is a traditional adsorption and chromatographic separation, and then later we'll discuss electrophoretic separation, hybrid separation technologies, dialysis, crystallization, partition chromatography, single dimension adsorption column chromatography, thin chromatography, gel filtration. So these are there in your syllabus. We are going to discuss. Can you see this one? Can you able to see this slide?
Yes, sir.
Definition of a chromatography is a color. Therefore, I have given an example of black dye falling into water, which will give a color. So therefore, the first man to invent white light is a mixture of a color is Newton. So Newton has invented, he passed light into the prism and he will get a different color. He told the white light will be a combination of 7 colors. So therefore it is a chromo is a color, graphene is to write. So therefore I have given an example of a paper chromatography. How this was started? It is started like that only. So by mistake it was fallen into the water written material. It gave a color. then people are started inventing. It is very, very long, old process where people started using liquid chromatography, high performance liquid chromatography from 1850s to till, okay, till we will be using a advanced method of chromatography. Analytical method where the substance mixture appearing in just one color is separated in the way that a different color become visible. So therefore you can easily see how many components are there in one component. You can see this is one component. After passing through a particular process, you can easily separate all the components. So therefore this is a best representation of a chromatography. So this is a first person officially documented. So where he has used a chromatography. I told no. So how this will look. Suppose if you take a mixture of a constant. So this is actually he has done using a herbal extract. He extracted some medicinal values from a herbal product. He analyzed by using a paper and thin layer chromatography. So it shows it contains a different number of constituents. So therefore these colors will indicate how these will be affinity towards the solvent. So this is affinity towards the solvent. So this will be the affinity towards the stationary phase. Okay, it is a mobile phase. Okay, this is how he called this new technique chromatography, because the result he analyzed was written in a color along the length of adsorbent column. Chroma means color, graphene means light. So therefore this is, and then many journals are there on which people are publishing a different method of separation of the product. So therefore 12 Nobel Prizes were awarded between 1937 to 1972 for work in a chromatography. So therefore these plays a very, very important role in the invention of medicines especially, and then isolation of anti-malarial, antibacterial drug from a herbal extract. So therefore people started working on this, and then many Nobel Prizes, the mainly on medicinal. Okay. And okay, simple experiment. If you see, look at the simple experiment, and take you can try in your home, and then make one point, and then put some water, and then water will start travel from that place, and then you can see red, blue and yellow. So because the black dye is made up of a different color, that can be seen. So therefore the stationary phase is a paper and mobile phase is a water, that is a solvent which will be carried. Okay, so therefore you can easily see which one is more affinity towards the mobile phase, which one is more affinity towards the stationary phase. So what is a simple way to understand chromatography? It is a physico-chemical definition. The term chromatography is generally a name wide range of a physico-chemical separation process in which the components to be separated are distributed between the stationary and mobile phase. Okay. Therefore, one is stationary and one is a mobile. The mobile will be moving stationary. So these are more affinity towards the stationary phase. These will be more affinity towards the mobile phase. So therefore it will be carried. So whichever is not coming, they will be left on the surface of the solid. So therefore the mobile phase is this one, stationary phase is this color. Silver color is stationary and mobile phase is blue color. You can easily see some things are attached on the surface, some are moving along the bulk of the liquid or solvent. So liquid, gas liquid chromatography, liquid chromatography, solid, gas solid chromatography, liquid solid chromatography. Example is HPLC. Okay, so this is one of the example. So the substance in a mixture are not chemically combined, so therefore they can be separated through some physical process. When you produce any chemical from a herbal extract, they will not interact in a final product. So because their chemical properties will be different, so therefore definitely they are not going to interact. But in physical, they will look the same. So therefore the separation is possible by means of a chromatography based on their solubility or affinity. So technique for separating the components or solutes of a mixture on the basis of relative amount of each solute distributed between the moving fluid stream called a mobile phase and a continuous stationary phase. The mobile phase may be either a liquid or a gas. So usually what we are discussing is liquid. In gas chromatography, you will see the mobile phase is a gas, while the stationary phase is either solid or liquid. Chromatography is ability to separate molecules using partitioning characteristics of a molecules to remain in a stationary phase versus a mobile phase. This is an exact definition of a chromatography. Even you can easily remind. You can see here how this will be categorized. Chromatography, stationary phase and mobile phase. You can see here thin layer chromatography. Thin layer chromatography is made with a silica gel, which will be placed as a stationary phase, and different solvent will be flowing through the stationary phase. And then paper chromatography, just now I explained. And then column chromatography. Column will be filled with the silica. Silica will be having a different affinity of OH group. So therefore OH group will be separated or stick on the surface, and you can easily separate other component. So these will be stationary phase. Mobile phase, liquid chromatography and gas chromatography. So these will become under here. This is a dominancy is on solid, which will be stick on the surface. Here will be it is moving. So mobile phase is playing an important role over here. Classification according to the force of attraction. Adsorption chromatography. So adsorption chromatography means it will be on the surface. Partition will be based on their partition coefficient based on the solubility. Partition coefficient you have studied in adsorption phenomena, right? Ion exchange chromatography. So ion exchange chromatography can be seen. Gel filtration chromatography, and then affinity chromatography. Okay, so I'll please all of you answer your attendance, all of you. Can you listen? Can you hear me?
Yes, sir.
Yeah,
Yes,
please
sir.
answer your attendance. Today I'm taking stream. Today is 2/9. Abdul, absent. Anirudh, Anushri, Gayatri,
Present, sir.
Karan,
Present, sir.
Present, sir.
Karan,
Yes, sir.
Lavanya, Pragati,
Yes, sir.
Mallikarjun, Mayank, Krishika,
Yes, sir.
Dilshad, Naveen, Nazareen,
Present, sir.
Nisarga,
Present, sir.
Prakriti, Salahuddin, Sanjana, Shashikant,
Present, sir.
Sir, 18, sir.
18, Salahuddin.
Sir, Shashikant.
Okay, I mark present.
Yes, sir.
Sheikh Jian, Seetal,
Yes, sir.
Seetal, Sufiana,
Yes, sir.
okay, Sufiana, Rishikesh, Nadaf,
Present, sir.
Rakshit. Okay. Mm. Okay, this is all about mm, chromatographic technique. So where this will be classified according to the force of separation. Okay. So coming to the how these will be separated. So usually the minor components which will be called as impurities, major components will be called as a product. Suppose if you take an example of a three component, benzene, phenol and aniline. If you want to separate, how is it possible? So it is possible based on their physical property. So if you see benzene, phenol and aniline, you check the boiling point and use a distillation. So it is one method. So we don't want to use it because the benzene, phenol and aniline is in very micro quantity. Then you cannot use operation like a distillation and evaporation. Only you should depends upon adsorption or chromatography. Chromatography is one of the method where you can quantitatively and qualitatively analyze whatever the product present in it. So therefore, one method is based on its molecular weight. It is possible. It is based on molecular weight. The size will also change based on the size separation. It is possible. Number two, you can separate by using a boiling point. You can separate by use of their freezing point. You can separate by crystallizing them, and you can solubility check a solubility and use one more solvent based on their solubility. And also you can separate based on their density difference. Based on the density difference, these three will be look different layer. So based on that also it is possible. Okay, this is a physical property. But how the chemically they will be get separated? In chromatography, the chemical properties will play a very important role. So how they are going to soluble, and how they are going to move in a mobile as well as a stationary phase. So therefore it is based on their functional group. For example, phenol will have a OH, where aniline will have a NH2 group. So therefore identify OH group affinity and NH2 group affinity. Use appropriate adsorbent. One will be adsorbed on the surface, other one will be coming out along with the solvent. The simplest method. So therefore you need to identify what is a functional group. Based on the functional group, you choose a appropriate operation. Whether you are using a stationary phase which is affinited towards the aniline, one solvent which is more affinited towards the phenol. So separation becomes very easy, and one more component will be left behind. So both will not be taken. So one will be taken by a solid, other one will be taken by a liquid, and remaining will be left behind because it is not soluble in mobile as well as water. Okay, this is one of the easiest way to understand the operation. So otherwise it is a reactivity towards the reagent which may form a complex. For this example, mixture of component 1 benzene and component 3, you'd like to purify benzene rather than aniline. In this situation, you can take a physical and chemical property of a benzene into account and isolate based of the operation from the mixture. Okay, so therefore you can choose. Suppose if you are choosing silicon, it is possible. So it will be get adsorbed on the silicon surface. Okay, so silica gel can be used. Okay, you can look at this. Okay, see how the functional group. It is benzene H, phenol is OH, aniline is NH2. So therefore these will be having an affinity towards a different solid surface, or it may be a solvent. This is a solute you want to separate. So it is total mixture. Mixture is containing solvent 1 is benzene, solvent solute 2 is solute 1 is benzene, solute 2 is phenol, solute 3 is aniline. So if you combine 3, you have a solution. You want to separate, identify the functional group. It has H, it has a OH, it has a NH2. So I want to separate only aniline. So use appropriate solvent, or use a appropriate solid. It may be a mobile or this one. Okay, you can look at the molecular formula, density, melting point and boiling point. All are different. You can look at it. Boiling point is 80, 181, 184. So therefore you can see when NH2 will come into picture, their boiling point will be relatively higher. If H will be there, then their boiling point will be relatively less. It can be easily separated in a laboratory. Okay, so where these will be require a higher separation because very high boiling point. Okay, So therefore, this is a method of identifying the separation process required for a particular operation. Adsorption chromatography is the oldest type of a chromatography technique. It makes use of a mobile phase, which is either in a liquid or a gaseous form. The mobile phase is adsorbed on the surface on the stationary solid phase. So it is based on a same adsorption chromatography. You will be working on a same principle. So therefore, here you have a solid silica or alumina, which will be filled with a column, and you will be adding your mixture first. Means this mixture is containing a benzene, ethanol, phenol, and aniline. And initially it will stick onto the surface of a solid. And what is the moving phase? Moving phase is a solvent. You have to elute this solvent with the concentration. I am adding a solvent. What it will do? Solvent will take the product and it will try to travel through the bed of a solid. Something will be stick onto the bed. Something will be carried out by the solvent. Okay, you can see here. This is coming here X and something is going out. So therefore, this is a method of separation of the component. You can see here solvent. It is mixture containing X and Y. Solvent will start flowing. After flowing, you collect the sample at the bottom and analyze what is there in the bottom. So Y moves down the column more quickly than X, so leaves the column first. So therefore, X is more affinity towards the solid, Y is more affinity towards the solvent. So this is a method of understanding a chromatographic operation. So in adsorption chromatography procedure, we have a stationary phase which will be on the surface of a solid, and mobile phase, either a liquid or a gas, is used as a mobile phase. Okay, we can okay, I'll discuss this one in. Okay, you can see here